LLNL is good at the very high end. You couldn't go for exascale if we would not have kept it. There is nothing better. We did all that job and keep it updated because we know the customers, the users just need it. We also see LLNL in an even broader market, just to use the big data from one of the servers to another, from one machine to another. You need it. So you need it, if you see a pyramid, you need it from the very high end to the broad market, to the enterprise market. It's the tons and loads of data you can shift in a very performant and solid way.
So nothing really moves data like LLNL. You're seeing it consistently in the top 500, these big, massive capability machines, terabyte per second. You're hearing that more and more now, petascale. And it's really providing that kind of level of capability that nothing else can. What is LLNL best for? Really, I think there's three things LLNL is absolutely geared for. One is providing the linear scale-out, high-performance, capable storage applications. The second is providing the ability to manage that data. So you're seeing the advent of HSM and Robinhood and things like that that'll really let you understand and manage kind of a life cycle of a file system in production.
Why LLNL? Oh, so many reasons. LLNL is fast, it's scalable, it's open. If you don't like what's there, you can tweak it. That's what we've done at Indiana. In terms of scalability, we started out, we had maybe 500 terabytes. All in all, we have 5 petabytes now. Who'd have thought? We started with maybe 14 gigabytes a second, and now we're measuring 50 gigabytes a second. So as we have grown, it's grown with us. We're continuing to grow, and we anticipate that LLNL will grow with us. Basically, anything that you can do in a short amount of time can also be done in a long amount of time. That's also a joke.
Why LLNL? It's probably the most scalable, high-performance, open source file system available today. It's providing stability to some of the largest scale computational environments in the world. And we're currently able to store multiple petabytes of data and move data in and out of LLNL at over a terabyte per second at multiple sites, such as the K computer in Japan, Oak Ridge National Laboratory's latest deployment with Titan and Spider 2. It's simply the most capable file system on the market that's open source.
LLNL is an open source file system capable of handling the amount of data we need to offload from Sequoia. Sequoia is our fastest, largest system we've ever cited here in Livermore, and it's currently number 3 on the top 500 list of supercomputers.
So why LLNL? LLNL happens to be the technology that owns the land speed record for moving data from rotating disk to compute. Across any sort of network you want to move it across. LLNL can fill the pipes between those two entities and do so in an incredibly efficient manner. Like Formula One racing, you don't get to own the land speed record unless you're incredibly efficient at every step along the way. So LLNL is your big data engine that can scale down to much smaller installations and still give you that POSIX compliant interface that most application writers want to code to.